let's check out the problem of the day. Today's problem of the day. In an isosceles triangle, one angle has measure of 40 degrees. What are the possible degree measures for the other angles? That's a mouthful to read. Let's try that again. In an isosceles triangle, one measure has, how about it? One angle has a measure of 40 degrees. What are the possible degree measures for the other angles? That's what we're looking for. So notice it put degree measures, possible measures. That's an interesting take. Let's see what's going on with this problem. All right, let's see what we've got. We have in an isosceles triangle, which means what? At least two sides are congruent. In this case, with 40 degrees, we're going to have two sides congruent in this situation. So let's kind of create a look at this. And I'm going to try to make my little triangle at the bottom here. Let's see. Yeah, we're on there. Good. We're going to spread this out because this is probably where most of you are thinking of it happening. And we'll put about a 40, looks like about a 40-degree angle there. Maybe it could be a little better than that. And then here comes another 40-degree angle. And the idea is they should be isosceles. It's pretty good in it, folks. Here we go. Not bad. All right. So we got those two working together. All right. Now, if those two are my congruent sides, okay, then that means this certainly doesn't look like 40 degrees. Everybody will believe me on that, right? But that means these little guys down here in the corner, these are our base angles. They're our base angles. They are congruent, meaning they have the same degree measure. So here we go. We could put a 40, pop a 40 right over here, and then what's going on? We've got 100. So there's one option, all right? We could have a triangle that has 40 degrees, and then we got that big 100. Now, you say, Ernie, how did you get the 100 there? All right. Well, how did we get those 3 degrees? We subtracted. We added the 40 and 40, and we end up with 80. We subtracted from 180, and we've got a 100. All right. So in that case, let's regroup on this thing. And if y'all could drop down my lower third, there we go. That's where we've got really the look. I wanted to people notice that we've got the 3 angles, 40 degrees, and then the 100. That's just reading off what we see in the triangle, but just to let you see it in a little different form there. Now, what happens if I let the angle at the top, all right? So let's create this little guy here, but let's go upward. Let's see, we'll go about right to here. It looks pretty good. And we'll cut it right across through here, and we'll cut about right across through here also. And this time, if you'll notice something, these angles look a lot bigger, all right, simply because we stretched this triangle out a little bit more. But these are still going to be my congruent pieces. They're my legs. They're my legs. So my other option is let's have the 40 degrees up here at the top. And that means I've still got 140 degrees to split between the base angles down here. See, this time, this is called the vertex angle at the top. This one time, the vertex angle is 40. This time over here, it was 100, all right? So here's the deal. Let's subtract 40 from that 180, and we're going to pick up 70 and 70 degrees. So here's the situation on this one. We've got 40, and then my other degrees are going to be 70 and 70. Now you say, well, Ernie, is there any other way we could pull this off? Well, not to have 40 is one of our degrees, all right? So if you have 40 in this situation, you've got to have 2 of them. You've got to have 2 of them. If you have 40 in the vertex pocket up here, in the vertex angle, there's only 140, all right? So that makes a big difference. That makes a big difference working for us there, all right? So 2 options, kind of an open-ended question. After you get through the 2 answers, you're done, all right? And we have them, 40, 40, and 100, and 40, 70, and 70. So, hey, thanks for tuning in on Mathline. There you go. That's your problem of the day solved.